All the information presented in this channel video is for education and informative purposes and only unusually presented in good faith. Welcome to my channel Rangeen Gyan. Please like and subscribe the channel. Welcome to the family of black holes. Black holes are most fascinating and strange objects in the fraternity of space. Black holes are those areas in space where large volumes of mass is accumulated in tiny portions of strong gravitational pull. They have the ability and power to capture the sense of light by the dint of their strong gravitational force. Our Milky Way could have possibly have more than millions of black holes that we could even dream of. The formation of black holes results from the death of a star, when a star loses all its charm and vitality after losing all its reserves of hydrogen. The stars then burst and eventually leave a reserve of dense mass with enormous sizes ranging million tons greater than that of the Sun. Although not all stars convert themselves to black holes upon their death, the formation of black holes also occurs due to the emission of gases. Black holes usually don't have the tendency to gulp everything, as we have wondered. They only have a sense of strong gravitational pull. Albert Einstein's theory of relativity pointed to the significance of black holes. It was later postulated by Carl Schwarzschild in the year 1915, taking cue from Albert Einstein. The term of Hawking radiation suggested that radiation is emitted by quantum effect from black holes near the vicinity of event horizons. The first occurrence of black hole was found in the Milky Way in the constellation of Cygnus and was hereby named as Cygnus X1. Black holes usually lose their vitality by evaporating themselves. Black holes usually have three layers named inner event horizon, outer event horizon, and singularity. The outer origin of black holes is surrounded by the event horizon, whereas singularity is in the inner epicenter of the black hole. Black holes are very hard to detect as astronomers look for dense mass of dust or gases. You will not see black holes, just as the way we see stars and planets. Scientists have classified black holes into three sections: chiefly stellar, supermassive, and intermediate. Stellar black holes, when a large star collapses by burning its last reserves of energy, such holes are created by the compression of stars that forms a mass of dust and gases in the surrounding atmosphere. These are then pulled by the stellar black holes. They then grow in constant rate and basis. Supermassive black holes. These giant black holes might be created by the merger of numerous black holes that lie at the core of every galaxy, including the Milky Way. Other causes of formation could be accumulation of large clouds of gases or all stars being pulled on together. Intermediate black holes. Such holes could be formed by the chain series collision cluster of stars. Such black holes then could fall into the epicenter of galaxy and then take the shape of giant deep massive black holes. Binary black holes. Such black holes could be created by the existence of two black holes in the same moment of time period, or it could be due to the birth of two identical stars being born and died at the same amount of time, thus creating the same amount of spin orientation. And the option being the formation of black holes, stellar formation, thus finally teaming up in totality. Oh my gosh, I found another class. Now our professor will accompany you in this journey. Welcome aboard. I am very excited to join you in the study, a fascinating study of black holes. Let us move ahead. Formation and type of black holes results primarily in the formation of chiefly four types of black holes. Stellar black holes form usually from the breakdown or collapse of massive stars. Supermassive black holes are found at the center of most galaxies with sizes ranging millions or billions more larger than that of our lovely Sun. Intermediate black holes are smaller than supermassive black holes but larger than stellar black holes. Primordial black holes are theoretical black holes that were born and formed in the same early phases of universe formation. Event horizon of black holes at those boundaries around black holes where the velocity required to get away from black hole is almost equal to the speed of light. It is the boundary beyond from which nothing can escape or get away from its hold. Singularity is an object or a point in a black hole where there is an infinite amount of density and an aura of gravity or pull at the center of a black hole. Accretion disk and black holes are a combination of gas, plasma, dust, or particles evolving around black hole. These materials evolving around black holes ultimately lose angular momentum and energy, and it starts to spiral inwards towards the black hole. Black hole jets are a type of energy stream of particles that are eventually ejected from the vicinity of black hole. When gas particles and dust fall into the vicinity of black holes, jet streams or jets are formed that are known to release some amount of energy. Space-time curvature of black hole revolves around the theory of Einstein's general relativity, where the corridors of space and time attains infinity in proportion. Yet the gravity is so rich that not even light can escape from its hold. Hawking radiation is another term coined by Stephen Hawking and results due to the quantum effect. Here, black holes emit thermal radiation from its event horizon. An information paradox in black hole periphery signifies the augmentative behavior between quantum theory and general relativity in the study of black holes. It's related that the loss of information occurs when matter falls into the hole. Black hole thermodynamics are studies of black holes in the framework of thermodynamic systems. It relates to the behavior of black holes within the arena of string theory with respect to factors of temperature, entropy, and energy. Accretion disk instability. Accretion disk is usually a circumstellar disk structure formed by diffuse materials in orbital motion that revolves around a massive body. Accretion disk instability is a phenomenon that involves a material in accretion disk to rotate inwards towards a central body. Accretion disk instability, as the material is thrust inward towards the central body, a process of heating and compression takes place. This results in the emission of electromagnetic radiation. Such properties can result from various factors of magnetic fields, gravitational forces, and other forms of black holes. Being just like other bodies, black holes also have a spinning phenomenon. It has an angular momentum and spirals around one of its axes of symmetry. The process of rotation affects its properties and the surrounding space-time associated with it. The ergosphere is a region around the black hole's event horizon where objects can be dragged along with its rotation. An ergosphere takes the shape of a flat spheroid ball and is useless matter and energy can be extracted from the corridors of a black hole. Photosphere is a spherical region around a black hole where photon particles orbit and revolve around in unstable circular orbits. It encompasses the boundary between the photons that are trapped by the black hole and those that escape from its hold. The tidal forces, the difference in gravitational forces between different parts of objects that can cause objects to stretch and expand into long, thin-shaped patterns, so termed as phagotification. Black holes occur in various sizes and proportions, ranging from a tiny speck of an atom to massive size worth millions times greater than that mass of sun. Actually, the mass of black hole determines the size and the extent of gravitational pull. Black hole charge. Certain types of black holes possess some amount of electric charge that can affect the overall properties. Black holes can either have positive or negative charges and occurs with types or without and with spin factors. Black hole here, a phenomenon which defines the properties of black holes beyond its charge, angular momentum, and mass. It is estimated that all matter which falls into the area of black hole leaves a mark in its gravity field. That very nature of stamp is called quantum here or black hole here. Black hole firewall. A hypothetical firewall could form itself near the event horizon of a black hole, and a spectator falling in the arena of black hole can encounter a high range of energy near the event horizon and probably reduce the access to the high energy and radiance of particles present at the firewall. The black hole complementarity. Black hole complementarity is usually a proposed measure and a resolution to the black hole information paradox. As of now, we have learned some exciting and fascinating things about the nature and properties of black holes. Now let us dive further to know about some important facts related to the study of holes. Black holes are those regions in space that experience a high amount of gravitational pull. The amount of pull is so strong that not even a speck of light can even escape from its hold. The theory of black hole was predicted by Albert Einstein's theory of general relativity in the year 1915. The boundary of a black hole is called the event horizon. The magnitude of escape velocity inside the black hole's event horizon exceeds the speed of light. Black holes can be formed from the remnants of giant massive stars after they have undergone a supernova explosion. Black holes fall primarily into three types of categories, namely stellar, supermassive, and intermediate. The stellar black holes have masses ranging from 3 times to tens of times than that of our lovely sun. Supermassive black holes have masses ranging from million to billion times than that of our sun and reside at the center of all galaxies. Intermediate black holes have masses that range in between that those of stellar and supermassive black holes. The largest known black hole is named Don 618 is one of supermassive black holes has an approximate mass of 66 billion times in that of our sun. Further, it has a diameter that ranges from a length of 30 to 40 times our solar system. The black hole closest to our Earth, thereby named as V616 Monocerotis, and lies an approximate length of 3,000 light years away. Black holes can merge with one another to create the same for larger black holes. When they merge, they have a capacity and a tendency to emit gravitational waves. Gravitational waves in the form of ripples in the fabric of space and time. The first direct form of observation of gravitational waves was made in LIGO in the year 2015. LIGO was here astutely called as Laser Interferometer Gravitational Wave Observatory. Black holes have the ability to spin. They do so because they possess the vitality of angular momentum of the matter that formed them. The spin of a black hole affects the shape of its event horizon. The most famous black hole seen in our culture can be visualized from the screening of the movie Interstellar. Black holes are often found in binary systems where they are found orbiting companion star. The presence of a black hole can be inferred by observing the motion of its moving companion star. Black holes can also be detected by X-rays emitted by matter falling into them. Matter falling into the black hole helps to form an accretion disk. As matter falling into the vicinity of a black hole creates an accretion disk, this accretion disk heats up due to friction and emits X-rays and other forms of radiation. The growth of supermassive black holes is thought to be linked up in the formation of galaxies. Black holes can grow by accreting matter and merging with other black holes. The process of consuming matter by black holes is termed as spaghettification. Spaghettification occurs since the gravitational force near the black hole is so much stronger. Time appears to slow down in the black hole due to intense factors of the gravitational field. This very effect is known as gravitational time dilation. It is said that if you fell into the black hole, then you will experience extreme tidal forces. These tidal forces then will stretch and compress you in such a way that you will certainly lose all your control of yourself and you will be torn apart into pieces. Stephen Hawking proposed that black holes emit radiation called Hawking radiation. Hawking radiation takes place due to properties of quantum effects near the event horizon. Over time, Hawking radiation can cause a black hole to lose mass and eventually evaporate itself. The temperature of Hawking radiation is inversely proportional to the mass of a black hole. Smaller black holes emit more Hawking radiation than larger ones. The time it takes for black holes to evaporate is extremely long, on the order of trillions of years. Some black holes might be primordial black holes which were formed shortly after the Big Bang. Primordial black holes could have masses ranging from microscopic to supermassive sizes. The idea of wormholes or shortcuts through the passage of space-time is very much related to the concept of black holes. A rotating black hole might have a region known as the ergosphere, which lies outside the event horizon. Objects can gain energy in the ergosphere by falling in and escaping. The no-hair theorem states that black holes can be completely described by the factors of mass, charge, and spin. The information paradox is a puzzle that relates to the activity of flow of information that falls into the vicinity of a black hole. Some theories suggest that information is preserved on the event horizon in a holographic form. Black holes play an important role in testing the theories and factors of quantum gravity. The study of black holes has led to important insights into the nature of space-time. The discovery of intermediate mass black holes challenges our understanding of their formation. Supermassive black holes are thought to exist at the centers of most of galaxies, including the Milky Way. The black hole at the center of the Milky Way is called the Sagittarius or SGRA. SGRA has a mass about 4 million times in that of Sun. The event horizon of SGRA has a diameter about 24 million kilometers. Its distance to Earth is estimated about 26,670 light years. The study of black holes involves multiple scientific fields such as astrophysics and general relativity. The observance of the effects of black holes helps scientists to learn about the behavior of matter under extreme conditions. Black holes can have jets of high-energy particles shooting out from their poles. These jets are powered by the energy released by matter falling into the black holes. The brightness of black holes' accretion disk can vary over time. Black holes can affect and influence the evolution of their host galaxies through the feedback process. The Event Horizon Telescope collaboration was able to capture the image of very first black hole in the recent years. Another supermassive black hole comes under the terminology of M87. The mass of M87 black hole is approximately 6.5 billion times more than that of our Sun. Black holes can be used to test the theory of general relativity and the strong field regime. The study of black holes has implications for understanding the fundamental laws of physics. There are still many open and unknown questions about the nature of black holes. Theoretical physicists continue to explore new ideas and further continue the journey of research about the various concepts related to the know-how of black holes. Some types of black holes might have hair or additional properties which have not been covered or described under the no-hair theorem. The detection and finding of the black holes with the help of gravitational waves has opened up a new chapter in the periphery of our universe. Scientists are on the hunt for new black holes through the help of various types of telescopes and good-natured observatories. The mass of a black hole can be measured by observing the motion of the nearby objects. Black holes can observe types of ranging from the factor 0 to nearby the speed of light. The spin of the black hole affects the behavior of its accretion disk and jets. The study of black holes has led to the development of new techniques and methods. New types of technologies are constantly on the way and are devised by eminent scientists and physicists for further development and research. Black holes are often depicted in many science fiction as a form of gateway or opening to other forms of dimensions of new type universes. While black holes are real, but the things or ideas depicted in science fictions are purely speculative. The understanding of black holes can help scientists a lot to learn about the early universe. Black holes can also influence the distribution of stars and gases in their host galaxies. The presence of supermassive black holes can affect the formation of new types of stars in the galaxy. Black holes are often found in clusters or groups. The interaction of black holes with the environment can lead to the formation of new structures. Black holes can be used in cosmic laboratories to study the laws of physics. The study of black holes involves the mix of theoretical work and observational data. Black holes can also have complex magnetic fields which affect the behavior of the accretion disks and jets. The study of black holes can provide insights into the nature of dark matter and energy. Black holes are an important part of the cosmic cycle of matter and energy. Some black holes can be formed with the collapse of giant and massive types of primordial stars. The existence of black holes challenges the understanding of our nature of reality. Some scientists speculate about the possibility of white holes, which are just theoretical opposites of black holes. Black holes can have significant impact on the host galaxies, including the appearance of regular star formation. Some black holes might be surrounded by dense clusters of stars and other dense objects. Black holes are a key area of research in the fields of modern astrophysics and cosmology. The study of black holes involves advanced mathematics and computer simulations. The study of black holes can help scientists in understanding the fate of the universe. Black holes can range from microscopic to supermassive sizes. The interaction of black holes with the environment can lead to the formation of new astrophysical phenomena. Now let us move to the final phases of a study of the fascinating world of black holes. We will have a further look into the observation and detection of black holes and the impact on future research related to the study of black holes. The gravitational waves, they are the ripples in the space-time caused by the merger of black holes. X-ray emissions. The accretion disks around black holes emits types of X-rays. The Event Horizon Telescope with global network telescopes used to image and assist in the study of black holes. Black hole shadows. The dark region in the center of accretion disks cast by the black hole. Galaxy formation and evolution. Supermassive black holes may play a massive role in the formation of galaxies. Cosmic sensors hypothesis, a type of conjecture that singularities are always hidden behind event horizons. Weak and strong types of cosmic sensors hypothesis exist in the global geometry and arena of spacetimes. Quantum gravity theory that aims to unify the concept of general relativity and quantum mechanics, which might help in the understanding and insights of the nature and study of black holes. Future missions, space missions like LISA, hereby called as Laser Interferometer Space Antenna, will study gravitational waves from the merger of black holes. We can certainly understand these concepts better as we delve deeper into the exciting world of black holes. After all, the existence of black holes caused an impressive role in understanding the nature of our universe in a big way. Well, it looks like that we have finally reached at the end of our discussion about the study and nature of black holes. We have tried our best to portray some important points related to the study and nature of black holes. Science is always evolving and new types of research might refine or change the aspects of these ideas. It is crucial to stay updated with the latest findings and new forms of research to understand more about our changing universe. Anyway, thanks for staying patient and showing an active interest in the study of black holes. Please consider subscribing to this channel, and thanks for sparing us precious time for watching this presentation. Bye bye, have a nice time.